All right, so example 3 on section 1.6. What is the solution of the system of linear equations 2x plus y minus z equals negative 10, negative x plus 2y plus z equals 3, and x plus 2y plus 3z equals 13? First thing I'm going to mention to you, the problems that I've made up for this section, I've actually made a worksheet for it, and the problems I picked out of the book all have solutions. Sometimes these don't have solutions, we'll worry about that another day. But right now I want you to have ones that have solutions, so know that everything you have will work out to some pretty little answer that has 3 values, x, y, and z. The solution should be written in x, y, z order. So your final answer should have that structure to it. Your task is to find out what x, y, and z equal. All right? And the first task, I honestly prefer elimination to substitution in all for technique most of the time. So more often than not, I'm going to use elimination almost every time on these problems to start off with. There's a couple cases where I might go substitution if there's a basic equation in there. When I have all 3 equations, have all 3 letters in them, elimination is almost always easier. Okay, so you have to make a decision to start off with. The decision comes down to what letter do you want to get rid of, and you have to do the same letter twice with 2 different sets of equations. So I'm going to pair up 2 of the equations, get rid of 1 letter, and then pair up a different 2 equations, get rid of the same letter. It's very important, same letter. So you get to make a choice, but once you make the choice, you can't change your mind. So when I'm looking at this, I'm looking at it's very, very easy to get rid of x on the bottom 2 equations. Can you guys see that all right? If I were to add the bottom 2 equations, these 2 equations together, negative and positive x are opposite each other. So that's going to be my first decision. I'm going to get rid of x by combining these 2 equations together in their current form exactly as they're written. No changes necessary. I always look for a no changes necessary scenario, because that's always the easiest. If I don't have to change anything, it's easier, right? So, negative x plus x cancels. 2y plus 2y is 4y. Z plus 3z is 4z. And 3 plus 13 is 16. Okay, my task here is to make a system of 2 equations like we saw yesterday by getting rid of the same letter twice. So my first equation in my system of 2 equations is going to have 4y plus 4z equals 16. Now, since this happened on this specific problem, let me bring it to your attention because it happens sometimes. It doesn't happen all the time, doesn't happen all that often really, but it happened to happen this time. 4 and 16 all divide by 4. You're not required to divide by 4, but divided by 4 makes everything smaller, so it's worthwhile to do it. So if this were me doing this problem, I would rewrite that as y plus z equals 4. Divide by 4 to make y, divide by 4 to make z, divide by 4 to make 4, instead of this equation. So again, my choice was, I'm going to get rid of x because it's easy to get rid of x. I added the y's and the z's and the constants to get this, and then I just happened to notice, hey look, everything divides by 4, let's go ahead and do that. All right? Everybody comfortable with what I've done so far? Moving right along, I'm going to erase all these marks up here because I'm going to make another decision now. I've already combined these 2 equations together here. Now I have to pick a different pair of equations, but I'm required, now that I've gotten rid of x once, I've got to get rid of x a second time. Getting rid of a different letter will not help me whatsoever. So, looking at my x's, here's all my x's here. Which 2 would be easy to get rid of?
2x and negative x.
The 2x and the negative x, right? So if I'm looking at this, I'm looking at these 2 equations here. I'm seeing all I really have to do is double this one. That'll make a negative 2x to go with my positive 2x. So I'm going to take the top equation and rewrite it as it is. So 2x plus y minus z equals negative 10. Multiplying 2 through this second equation, 2 times negative x makes negative 2x. 2 times 2y is positive 4y. 2 times z is positive 2z. And 2 times 3 is positive 6. If I add those 2 equations together in their current form, again, the top stayed the same. The middle multiplied by 2 to make this. Everything got doubled. 2x minus 2x cancels, getting rid of x a second time. Y plus 4y is 5y. Negative z plus 2z is positive 1z. And negative 10 plus 6 is negative 4. So I've got 5y plus z equals negative 4. So I went from a system of 3 equations with 3 variables. I eliminated x once to get y plus z equals 4. I eliminated x a second time to get 5y plus z equals negative 4. And now, instead of having a system of 3 equations with 3 unknowns, I'm looking just at this problem, which is what we had to do last night, 2 equations with 2 unknowns. So, looking at these, again, I'm going to make decisions. I've got x, sorry, I got y and I got z. I've got to get rid of one or the other by elimination again. What's easier to get rid of, y or z? Z, right? Because 1z is exactly the same as 1z. All we have to do is get the signs changed in one of the 2 equations. Doesn't even matter which one you change the signs on. So do you guys want to change the top signs or the bottom signs? Top. Okay, so I'm going to take these pieces, y plus z equals 4, and make it negative y minus z equals negative 4. Alright, so 5y minus y makes 4y. Z minus z cancels. Negative 4 plus negative 4 makes negative 8. And 4y equals negative 8, we divide both sides by 4. Y equals negative 2. Again, my answer is in order triple, x, y, z order. So what I've gotten so far is that. So I'm going to put my answer over there. Big red answer. Y equals negative 2, y goes in the middle. Once we know what y equals, now I'm going to go and find out what something else equals. And the easiest place to go to find out what something else equals once you know anything is go back to an equation with that letter and only one other letter. So either there or there. I know what y equals, I want to know what z equals. So I can either go negative 2 plus z equals 4. Right? I just took that equation right there, changed y to negative 2. I don't know what z is yet. It's supposed to equal 4. I move my 2 over, so z equals 6. I could have also gone down here to the green one. 5 times y, that's 5 times negative 2, plus z equals negative 4. 5 times negative 2 is negative 10. Move the 10 over, makes it positive 10. Negative 4 plus 10 equals positive 6. It's the same answer because, again, this is the right answer for y. Z only has one answer, so whichever one I go back to, I should get the same result. This one was easier, right? So make a decision when you go back, what looks easier? Everything positive with small numbers, everything positive except that's negative, that's a bigger number. That's easier, right? Z equals 6. Now we have 2 answers. Once we know 2 of the 3 answers, all we have to do to find the 3rd answer is go back to the original problem as it's written up here. I go before I modified anything. So, looking at the 3 equations, 2x plus y minus z equals negative 10, negative x plus 2y plus z equals 3, and x plus 2y plus 3z equals 13. Which of those 3 looks easiest to work with?
Bottom.
Why?
Is there all positive?
Everything's positive on the bottom. Positive is easier than negative, right? So let's go with the bottom. I can go any one of the 3 and I'll get the right answer, but I'm going to go to the bottom because everything looks easier on the bottom. We know what y equals, negative 2. We know what z equals, positive 6. We do not know what x equals. We're going to keep x as is. So x stays x, plus 2y becomes plus 2 times negative 2, plus 3z becomes plus 3 times positive 6, equals 13, stays equals 13. Again, I know some specific values over there. I simply replace those y and z's with those specific values that I know into the equation at the bottom. If I evaluate, 2 times negative 2 makes minus 4, 3 times 6 makes plus 18, that equals 13. I would probably just move everything over and then evaluate. So negative 4 moves over as a positive 4. Positive 18 moves over as negative 18. 17 minus 18 is negative 1. X goes in front. Once you know all 3 numbers, that's your answer.